Ladies and gentlemen, we are coming to our next BIM virtual session. Now we are heading to UK to the company Buildots, and the co-founder Aviv Leibovici will be with me, and he will tell us more about enhanced collaborations through AI and BIM. So I want to hand over the virtual stage. So the virtual stage is yours, Aviv.
I'll start by telling everyone a bit about myself and about Buildots. And what it is, or maybe start even a bit before that with why it is that we built this product and that we're doing this. So in essence, what we came into this construction industry, and what we understood is that there's a very big gap in the way that managers on site are expected to manage the project. Why is that? It's because construction is very, very complex, and within that, the only solution that a manager has on site to truly know what's going on in order to manage the process is to do so manually. So to walk around, to look, and to check every little detail manually. And that, combined with that complexity, makes it something that is in our minds at least, not very possible in a way to manage properly. And the task that construction managers on site are faced with is not real in a way. It's just inhumane. And I think this quote here that I have from one of the project managers that we're working with is something that really speaks to that, because they just said, well, I don't know that an activity is going to be late until the date where it was supposed to be completed but was not. And then I say, okay, so it's probably late. That brings me to what our mission is and what we're trying to do. So in a way, we're trying to build a construction control center and to provide managers with all the information that they need, the right information and the right way to better manage this process. For us, that includes it being very accurate and objective and detailed. So knowing exactly what's going on down to the element level in an objective way that was captured in the same way every time. But it also has to be very frequent, because if you have information from 2 weeks ago and you can't use that to manage your process, you can use that for all sorts of other things, but not for management purposes. And finally, it has to be collected in one place and accessible for all. The way we do this today is this. So our product is based on captures from 360-degree cameras. These are just standard 360-degree cameras, Rico, Garmin, and the like. Those will be mounted on Those will be mounted on a hard hat of the team on site. And as they walk around, a video will be captured. And what our tech will do is it will use that. One second, apologies, but this needs fixing. There we go. So it will use the images from the video and the model and join the two together to understand what is going on. So basically to know what status every element of this construction is in right now. So this socket could be a hole in the wall, and that wall could be painted, and that's the sort of information that it captures. And then connect that with the plan as well, with the schedule, to understand how things are going and how are the different activities and packages going and all of those things. And it's all then delivered on a web application that is what our customers use. This is what I'll show to try and explain a bit better of how it actually works. We're seeing a snapshot from our system here. What we're seeing is that the camera on this frame was positioned here, and it was looking at this specific element. So this is a wall. Now we're seeing here that this white overlay shows where the system, based on the model, is expecting to see the element. And then it's saying, well, the element is indeed done on this date here, which is why it's shown in green on this drawing here. And that's the way that we work. That's the way the system works. It finds the locations of the camera, it understands which elements are around it, and it analyzes each element in this way from this visual capture. That is what I will say about directly, let's call it about Buildots today. And I'll try now to speak a bit about how we use BIM and how we use BIM and AI to support collaboration on site, and give a few examples as well. So first, how we see BIM today. So for me, BIM, the main effect that it has is on the collaboration during the design phase. Basically, collaboration for what purpose? Because it creates, I called it higher quality designs, but basically things that are more constructible. By that, what I mean is we're just now in the process of sort of a research, an internal research, to understand how commercial fit out of office spaces in the UK, how those projects look like, and how they operate, and the do's and don'ts of those projects, just to see how well our system can work in different sorts of projects. And what we're seeing there is that the go-to answer of people on site to the question, how strictly do you follow designs? How much is what is constructed? How much does that follow the design that was agreed on originally? It's very, very connected with BIM. The more BIM was used and the higher level of BIM, then what's being built is closer to the design. So for me, that's the main effect of BIM. It builds designs, it creates designs that we can actually build as they are. And that, of course, has a very significant effect on everything that happens on site. It is also an enabler for advanced technologies. Ours is an example, but AR systems are another. Basically, a lot of technologies in the world today that cannot work without BIM because they need this model and not just drawings. Now, specifically about us, why do we use BIM? So our system only works on projects that are modeled. It cannot work on projects that have 2D designs, that have CAD designs. And why is that? First is this idea that I called it design for production, but it goes back to what I said before. So basically, if you have a project where you know that what's about to be built is exactly the design, and there will be fewer decisions made on site to deviate from that design, then that's something that you know what you're verifying in a way. So if you look at BIM as a whole, and if you look at the project, at the end of the day, if we know that what is being built is exactly the design, and any deviation from that design is an anomaly, then that's something that a machine can track. Because a person can walk into a room and just say, oh yeah, the pipes are in here, it looks all good. A machine can't do that. A machine has to know exactly what it is it's trying to verify. And therefore, our AI system that verifies the progress and verifies the work on site can only work in a world where it knows what to expect. And that world is a world where everything was designed in BIM. So in short, we need BIM, and we also use AI and need AI. Those two are the enablers to be able to provide truly quality information to the site team. It doesn't work without it. Okay, now I will move to giving some sort of background about how we use BIM, BIM and AI, specifically for this idea of objective information and collaboration, and why that is key. So first, to start, my first claim is that to truly collaborate on site between different parties, you need objective data. And the first question might be why? Why is that really required? Now, my answer to this is that all the discussions that happen on site, blame games, people not knowing who to trust and what they can or cannot do, all of that is a result of the lack of data, the lack of credible data. The fact that no one has the answer to what's truly happening is what causes all this friction. And bottom line, from my experience, it's not that anyone is lying. It's not that someone is saying that they did something that they know they did not, or anything of the sort. It's just that they don't have the full image. They don't have the full picture of what's happening. And they will not assume that they are the ones at fault. Nobody just assumes that if there's anything missing or any problem, or just even if things are good or not, nobody assumes the worst in these situations, especially when it's a relationship between different businesses and all the complexity that brings, whether it is main contractor, subcontractor, design teams, etc. That's just not a simple situation. And actually, from my experience, this lack of information not only does it cause friction when there are issues, but actually even when everything is going well, it's going great, everyone is sort of doubtful, and everyone raises the question to themselves first of what's happening here, and can we really do what we think we can do now, just because they know that part of life on site is that something unexpected might be found out at some point. So all that explains why, for me, I think that Buildots does a lot of things. It does, we track progress automatically, and we create an automatic sort of drop line with the schedule. We provide early warnings for things that are built incorrectly or things that are missing. We do a lot of things, but today my goal is to focus on the use of BIM, which has become a collaboration tool in design, and with AI making it a collaboration tool during construction as well. So that was my focus, and that is my focus, and I will give a few examples now of how we've seen that happening on construction projects where we operate. Okay, example one would be one of, I call it unified design, but basically managing designs and what that could bring and what happens on projects. And this is the sort of thing that we all know. But to give some background, this is a 100 million pounds project in London. The frame itself is a lightweight steel frame, so this is not a concrete building. It's just steel. That frame has a total of 3,500 almost load-bearing walls, so frame walls, and in 820 of those, there's an opening for a door or a window. So that's just information on that package, and there's a package manager specifically running this package, and there's one site manager per 3,000 square meters. So there is a pretty good management team running this and with focus on this specific package. Now, what happened on this project is that Buildots was deployed and captured, and you can see here, it might be a bit difficult to see, but what you can see here on the image is this wall, one wall from the lightweight steel frame that should have an opening here for a door, but it doesn't, and there's cross bracing going through and studs going through. And this was captured using Buildots. The system then analyzed this wall and immediately flagged an error saying, well, there should be an opening here, but it's not trimmed and it's not ready. When you go and find out what happened here, so actually this was an issue caused by just design management, let's call it. So the subcontractor building this wall and the frame in general built to their designs, but their designs did not show an opening here. And this is one example of something that we've seen happen quite a lot, where a subcontractor on site will use a design that is not fully up to date or just not correct, but because our system tracks against BIM, BIM being the source of truth for design, then actually we have something here, a tool that verifies the construction versus the true designs. Therefore, even if you have a problem with management or with what drawings people are using on site, that is flagged very early. And this specific thing could have been a massive headache if this wall was already boarded, maybe then painted. If this apartment was complete, whenever it was found out, and somebody was coming in to install the doors saying, hey, I don't have a door here. At that point, it would have been a massive headache for everyone, for the main and subcontractor. And finding it out soon just makes it a whole lot easier. And if you're talking about collaboration, this is the sort of thing that everyone's happy with, because the sub can fix it now, and it's an easy thing, and it was fixed in a matter of days. And having this source of truth, this system that just says and tracks everything against the latest model, just facilitates collaboration between everyone and reduces friction that could have been caused when this would have been found out. Second example is of just a Windows installation package in one project. Again, project in London, and the package, of course, included mounting those windows and then sealing them, EPDM sealing them, air seal around the window. And the expected throughput was for 5 apartments per week. So it's a residential scheme, and we're expecting windows to be completed in 5 apartments each week. And the project team experienced some problems. They knew that they're not really hitting that mark, and that things are not going as expected. But as someone on site told me, there's a difference between knowing and seeing. And then what we did together with them is this. So what we're seeing here on the right is 2 snapshots from our system. One is showing that actually the pace of work is going above the expected one. We can see that what we're seeing in this graph is in gray, the planned progress through time, and in green, the actual progress. So they started late, and this is due to COVID, but then you can see that the pace is much faster because it's catching up than the one planned. So that's going pretty well, but still there are problems. And why are there problems? Because looking at this analysis, we can see the amount of apartments at each point in time that have at least one window installed and at least one window not installed. So actually what happened here is that the work was being done at the correct pace, but was not focused properly. And the result of this was the main contractor and subcontractor for windows on this project sitting down together and discussing it and saying, well, you know what we can do is focus now, just focus on making sure we complete apartments and don't work everywhere in a scattered way. And they actually agreed to increase the expected pace from 5 apartments per week to 8. So they had problems, but what they could do using the information is agree together. This was a very simple conversation between them, where the main contractor, using our information, showed the subcontractor, hey, look, you can do even 8. You just need to focus on completing apartments. And that's what they agreed. And the ease in which this sort of conversation goes when you're using data that is backed up by images, and you can always click things here and see images, is very simple. And it actually brought the subcontractor to a point where they say, well, actually, this is easy for me. Yeah, if this is what I'm doing, then sure thing, let's go for it. And when I speak about collaboration using data, this is the sort of example that really strikes that. Another one is of BUILDERSWORK holes, so service openings like this one here. What's happening in this, it's again a lightweight steel frame job. And what's happening is that you have service openings that need to be in the walls. The way this is done is that the lightweight steel frame contractor will trim them, will create this sort of preparation for the opening. And then when the dryliners come in, they leave it open as such. So they will board the wall, but leave this specific part that is trimmed out open. That's the way they do this, and that's the way it's basically run. What happened is that this is a multiple building project, and when the duct installers came in to install ductwork on the first building, they actually saw that they have a few openings missing and came up with a number that 35 of these are missing. So 35 openings all across this four-story building were missing, and they couldn't install their ducts because they didn't have how to mount them. In a meeting that I was in, the lightweight steel frame contractor took responsibility for 3, saying, okay, we checked. We know of 3 that we did not trim originally. We did not do this. So that's on us, and we'll go and fix that. And the dryliners knew of 1, where the trimming was there, but they boarded it. But the obvious question is okay, but 3 plus 1 is not 35. So where are the other 31? And what we did here is that we configured Buildots to track these openings, which was not a part of what it was tracking before. And you could easily see, because it analyzed all these images, which elements were trimmed but then boarded, and which elements were just never trimmed, and therefore that is the error. And in a matter of a day after we just added it to be analyzed, it came up that 25 specific openings were due to the lightweight steel frame contractor, so they were not trimmed, and 10 were trimmed but then covered up with dryline. And I think the key point of this story is that once that was there, that's it. There was no more argument. There was no more discussion. Each of these parties were happy to go and fix their own mistake because they knew that it's up to them. Whereas before, without knowing that it is their fault, they don't want to go and do extra work that might not be might not be theirs to do. But now, seeing that this is the case, they just immediately said, well, okay, fine, I can see the images, I can see the analysis, I'll go and complete these 25, you'll go and complete these 10. That's up to me, that's up to you. And everyone's happy. And I think that, again, this is the idea of information. Everyone can just collaborate and everyone agrees very quickly, because people, when they know who needs to do what and what is in whose responsibility, just agree quickly and go ahead and do it. And even the atmosphere on site becomes so much better because there's so much less arguments and friction. Another example is of a pace of work for drylining. So in the first 2 floors of this building, this was analyzed, and the drylining was planned for 2 weeks per floor. So it was meant to complete a floor of drylining with the first visit in 2 weeks. And internal works, so drylining as the first package, started right on schedule. What immediately happened is that they started losing time. Why? Because first floor was predicted to and then was completed in 4 weeks instead of the 2. And the team started discussing, why is this happening? You were meant to do this in 2 weeks, why are you doing it in 4? The dryliners truly believe that they just can't do it in 2, that there are too many things to do, too many tasks, and they're all dependent, and you have to do one after the other, and you can't complete it in 2 weeks. It's not really feasible. But what the main contractor asked us to do, and what we did, is we provided data that actually showed that they did half of the floor sort of in a pace that matches 2 weeks. So they did 50% of the apartments in a floor in a week. So that means that they can complete the entire floor in 2 weeks. It's just a matter of labor, because they weren't utilizing all the space well enough. They weren't working on all the apartments at the same pace on the floor. And showing that to the subcontractor here actually got them to increase labor on site right the next week. It wasn't a problem, because once they knew that if they bring in more people, they will be effective and productive, then it was a no-brainer, and they brought them in, and the 2-week target was met. And again, very easy to agree on what to do or not to do when you base it off this objective information. Final story is of a sort of a unique situation. So this is a commercial office space. And what happens here is that the communications themselves, so the cabling and installment of network data points and the such, is done by a special contractor, subcontractor, that is brought in by the client. Specifically, that one is not hired by the main contractor, but rather hired by the client, because they want to ensure that they work with people who they know won't do anything funny, let's call it, to their network. And they'll keep their data secure once they work in this office. And that's a very standard procedure that happens on all their projects, wherever they build the specific company. And it usually causes a lot of friction. Why? Because this contractor needs to know when to come in, and they actually a lot of times come in from abroad. They don't come in, they're not a local contractor. And they need to know when they come in, and they base that off the main contractor on site telling them, well, it's ready for you. All the cable trays are in, everything is ready, you can come in. And a lot of times what happens is they will come in and it won't be ready. And then they will sort of say, okay, what now? Maybe I need to go and come back, or wait a week. There's a lot of friction around that of, is it truly ready for them? And in this case, we can see two sort of images here of how Buildots helped solve that. Basically, this is an image showing cable trays all across this floor of this specific office. And you can see that all the elements are marked in green. Why are they marked in green? A bit difficult to see in this image, but we're seeing, again, the overlay of where the cable tray should be. And the cable tray is actually there in the image. You can see it here. It's not very, very easily visible, but you can see it here. And that's why this specific element, it's one of these, is marked in green. And all of these are in green because the system verified that they're all installed as per the BIM model and as per the design. Using this, it's very easy. Once this is the situation, the special subcontractor comes in without a problem. And also, even before that, they can expect when things will be ready for them because the system analyzes the work and analyzes the pace, and then they can know when they're expected to come in. And for them, solving this issue and now being able to agree easily together on scheduling of when they should come in, because there's this credible data, is just super easy. And this is of course due to the fact that everything is tracked against the model. So this cannot be done without a model, because we have to know that the designs are exactly followed and that everything is done 100% and is 100% ready for the team to come in. And it worked, and they came in and completed the work in one visit, a few days, very simple stuff. So finally, I will just say one thing, which I think is something that I learned during the last 2 years of us building this project. We started with we started with building a solution that we believed the key effect of it was to give main contractors control over the process. And that is still a very, very big item, and it's still the key item, knowing if things are truly complete, knowing if anything was built wrongly and correcting that, knowing the pace of work and how to manage that and how is that versus your schedule, all that is key. But also the ability to move beyond the arguments that a lot of times happen on site and the discussions, and working together as a united team, because everyone has a common ground, which is this common database, knowing exactly what's happening. And it's not something someone said, it's just an analysis that is being complete, is very big. And I've found that to be a very significant effect on just how projects are run and how they happen.
Aviv,
that is
thanks
it.
so much for these deep insights. I mean, you have shown us how to avoid the blame game on site. That's
Yes.
really important. We don't have more time. Sorry for that. I have plenty of questions. I think one question we could have: how do you work with the ISF model? So, we have learned that you work mainly with light-weight steel frames systems. So this is perhaps one of the core elements at the moment. So there you are using IFC models, perhaps. But how will you now enlarge your data set?
Yeah, sure. So actually, there were a few examples there of lightweight steel frames, but we actually today, what we track is anything that is modeled. So that is, going back to what I said about the system needing BIM to be able to track what's happening. So we can track anything that is in the model. So if you have sockets, we can track sockets. If you don't, we cannot. If you have windows, we can track windows. If you don't, we cannot. That's basically the way it works. The system can also understand some things outside of the model, things that are very clear. It basically needs the model to understand where everything should be. So if there's a way to know without the model, for instance, even if paint is not modeled, you know that every wall and every ceiling needs to be painted, then that works as well.
Okay, but you have to train your system in a way.
Yeah, the system is trained. It's trained constantly and on different elements, and we have this way of how it works.
Ladies and gentlemen, if you have further questions to Aviv, he is available in our exhibition space, and he is happy to answer your questions. You could also make appointments with him. So we are looking forward that you engage with Aviv. Perhaps you can find a collaboration way, and Aviv on that way a new customer. Thanks so much for your support, and thanks for being with us, Aviv. I wish you now a nice networking at the BIM Virtual, and hope to see you soon. Perhaps on the virtual beer or something. Yeah, Aviv, thanks. Bye-bye.
Thank you very much.